Welcome to another module of Tennessee Smart Yards. My name is Celeste Scott. I'm a UT Extension agent in Madison County, and I'm going to be helping you all along with your discussion today. So if you have participated in any of the other Tennessee Smart Yard sessions, I'm sure that you know that this program focuses on 9 basic principles involved with creating a sustainable landscape. One that can be attractive and meet your family's needs, while also helping protect our community and state's natural resources and waterways. So today we're going to be addressing managing yard pests in the lawn and landscape. So this is our yardstick, marking our inching towards success with Tennessee Smart Yards, and this kind of just lists out some basic learning objectives that we're going to address today, and we will make sure that we check each one of these inches off for you today in this module. So we're going to start out talking about pest management in the landscape by addressing a practice known as Integrated Pest Management, or IPM. This IPM is a multi-step approach to maintaining pest populations below levels that could cause, objectionable damage. Now, that can differ depending on the situation. In a vegetable garden, damage would be loss of fruit. In an ornamental garden, damage would be mostly aesthetic. So then you have to, thresholds come into play. How much are you willing to how much damage are you actually willing to tolerate due to that pest, whether it's insect or disease. A second objective of IPM is not to necessarily eliminate pesticides as a management option, but to optimize pesticide use, within biologically based pest management decisions, and to limit or replace chemical pesticides with environmentally friendly options when possible. So we're going to take a holistic look at insect and disease management. And as you can tell from this graphic, it's almost a cyclic situation. We're going to start by talking a little bit about monitoring pests in our garden and how to identify them, because those steps are very important. We can't jump to a treatment option before we have identified what the issues are. Of course, determining a threshold, and then finally some different options for treatment or control. So we're going to start off talking a little bit about scouting, and this is one of my favorite things to do. I have a little bag and I put all my scouting tools in there. It's your little toolbox, if you will. And I like to keep a magnifier, kind of like a little hand lens, or magnifying glass, whatever you have. I like to keep that on hand, and that can help you see really small insects like mites, some different types of scale, and in some cases it helps you identify some of the feeding patterns that you might see on leaves. So hand lenses are must have those in your scouting bag. Also like to keep some Post-its and pen and paper in there, just so I can make labels of things. Some Ziploc bags in case I need to take any samples. I keep a hand trowel in there. Oftentimes you need to dig around at soil level and make sure the roots are healthy. Maybe the issue is a root rot condition or something of that matter. So I like to keep a trowel. I like to keep a pair of hand pruners or a pocket knife in there so that I can check the insides of a stick or peel off the bark and see what the inside of that looks like, make sure there's no discoloration. So those are some helpful things. Also, double-sided sticky tape, that could be a really good monitoring tool. You could put that on plants that are typically inundated with a scale or different insect, and as it crawls across that sticky tape, it will get stuck. So those are some useful things that you could have on hand. Also, I would recommend just keeping a really good notebook of what's going on. You don't have to inspect every single plant in your garden every time you go out to do a scouting mission. You can, check here and there, but let's just keep a record of it so you don't always check the same plant every single time. We're making sure to spread that around to different areas of the garden. So once we've done a pretty good job of scouting our gardens and getting familiar with what should be there and the types of things that we're seeing, we need to talk a little bit about identification. Now, we don't have enough time today to go all the way in depth on disease and insect ID, but I am going to hit the highlights, and we're going to talk about being able to identify the different types of feeding, and then make sure that you are aware that there are some specific key plant-pest relationships to be aware of. And this is going to help you come to a determination, or it's going to help you, if you use your extension agent to help you determine what's going on, you're going to be equipped to answer the types of questions that they're going to ask you. So that's what we're going to focus on today. So we're going to talk a little bit about signs and symptoms of disease. Plants often have diagnostic symptoms for different diseases, and many of the descriptive words are used by the experts as well. So we want to try and describe the symptoms as accurately as possible. A leaf spot is different than leaves that are obviously wilting or turning yellow. And an accurate description of what's going on with that plant can be the key difference in you determining if that is a disease or if that is an insect feeding issue. So we want to be very specific and detailed in our descriptions of what we are seeing. So here, the picture on the top left, this is a cedar apple rust, and it is a gelatinous, horny gall would be a good way to describe this. If you ever saw it in person, it is gelatinous. It's kind of wet and like a jelly. And so we need to, be aware that this is something that's out there. This would be considered a sign of a disease. This is part of the fruiting body, if you will, of that particular disease. Moving right along, the second picture at the top, the green with the white little dots on the leaves there, that is powdery mildew. This would also be considered a sign of the actual disease itself forming on the leaf. You could rub your finger across that, and that powdery substance would come right off. So that would be considered a sign. That is the physical disease itself on the plant. Another example of a sign of disease is the picture here on the top right. Looks kind of like cobwebs with little balls in it. That is southern blight that is seen oftentimes at the base of tomatoes. I've seen it on hydrangea and many other ornamental plants in the landscape. This disease, what we're looking at here is the white cottony substance is the mycelium, and then those little balls are called sclerotia. Those are the fruiting bodies of that disease. So here we're seeing a sign. We know that this is the disease. Now, moving on from signs, we're going to talk a little bit about symptoms of disease and how those can oftentimes be confused with feeding patterns of insects. And so it's important for us to be able to at least be aware that there could be similarities between those. So the picture here on the right looks like a stick with a kind of a circle in the middle of it. That's an example of a canker. And cankers can come in lots of different shapes, forms, and fashions. But essentially, you're looking for something that looks abnormal on a twig or a limb. A sunken area, a dark spot, somewhere where death of that plant tissue is happening. And that is what we refer to as a canker. The picture down here on the bottom right is a gall. So if you ever see a strange growth on a twig or a limb, you know that this, a word to use to describe that could be a gall or some kind of unusual growth on that plant material. The next picture here on the bottom center, this would be a good example of necrosis. So if you have some plant material that the tissue is just dying and turning brown, we would say that that is necrotic. This is also a good example of something that is happening interveinally. If you can see, I'm going to get my highlighter on here so you can see. Here are the veins of this leaf, and you can tell that the necrosis is happening in between the veins. The veins themselves are not becoming chlorotic. So that's going to be a good descriptor for you to use with your extension agent or professional when you're trying to identify what's going on. This next picture here to the left, this is also a good example of intervenal symptoms. Now this, on the other hand, we would refer to as chlorotic. It is losing its green color and is turning yellow in between those veins. So we would say this would be intervenal chlorosis. And then our final picture here, there can be millions of different kinds of leaf spots, but it's important to be able to communicate this and describe to people exactly what these spots look like. Now we may describe this as a target spot. If you could see, it's white in the center, it gets lighter, and then there's a darker band around the outside. In some situations, it's even important to note a difference in color. So making sure that we tell the person the centers are papery and white, and the outer border is purple or the outer border is red. Those can be indicators of specific types of diseases. So let's just be aware of what's going on, and I just wanted to equip you all with some terms that are going to help you describe more accurately what's going on with your plants. Now we're going to move on and talk a little bit about signs and symptoms of insect damage. I'll get all my pictures up here. So we have a few different feeding patterns. Sucking, chewing, and internal feeding are the three main ones that we're going to talk about today. And we're going to start up here on the top left. And this is an azalea leaf that has been infested with the azalea lace bug, and it is a sucking insect. So they have a piercing mouth part that sucks all those plant juices out and creates little bitty chlorotic spots. Now when you have a bunch of very small pinpricked chlorotic areas together, we call that stippling. And from far away, it can almost have kind of a silvery cast or appearance to it. So I just wanted to show you all some of the different side effects that feeding sucking insects can have on plants. Now this next one in the center here, this is this is black sooty mold on the leaf surface. Sooty mold is created by honeydew that is excreted from a sucking insect. So they excrete this honeydew substance. It's sweet and sticky, and that's the perfect environment for the development of black sooty mold. So the mold itself isn't causing an issue except hindering photosynthesis by covering the leaf surface, but the main issue is that sucking, feeding insect, and this can be a great indicator for us. So these are all symptoms of what these insects might do to a plant. Another one here on the top right, this is an example of what could happen if you have a very heavy infestation of aphids. Aphids are sucking insects, have those sucking mouth parts. They can feed so heavily in the new tissue of soft herbaceous type plants that it can actually cause some distortion of the leaf, curling, folding, and can sometimes be mistaken for chemical or herbicide damage. So we always want to make sure that we check every avenue of possibility before we begin to lay blame for one thing or another. So earlier we talked about the differences in signs and symptoms of diseases, and basically a sign is the actual disease itself. So with insects, a sign of insect feeding would be the actual insect itself. In this picture here, we see a rose slug. So if I saw the rose slug there, I'm saying we've got a pretty positive sign that we've got rose slug damage. Now, a symptom is something that is caused by the disease or is caused by the insect feeding. So all these that we've talked about so far, I think would fall in the symptoms category. The picture here in the bottom right, I'm sorry it got covered up by the rose slug picture, but this is a picture of a Japanese beetle feeding on a leaf, and you can see how they have really turned this leaf into a beautiful lacy pattern. Yeah, right. This is something that we don't want, but you might refer to this as skeletonizing. So that could be a term if a professional is asking you to describe to them the type of feeding damage. If there are actual holes in the leaf, we do have some different words used to describe that. So that would be called skeletonizing, where you have feeding in between all of those veins, and they are leaving the bones or the veins of the leaf, but taking out all the tissue in between. Another good descriptor word is window painting, and that is what this rose slug here is doing. Their mouth parts, just like Japanese beetles, they have chewing mouth parts, not sucking mouth parts, and they can't chew all the way through the leaf, so they can only scrape off the top layer. And so what they leave is a really fine, transparent area in all the places where they fed, and eventually, after time, those will become dried out and papery, and when the wind blows, those holes will fall out. So be aware that could happen, but that type of feeding damage would be called window painting. And then we move over here. This is a picture of some roots that have been infested with some internal feeders, like a root knot nematode, for example. So, roots are not supposed to naturally be bulbous like this and have all these nutlets all over them. They're supposed to be fine and white. So if you dig a plant up and see that, that could be a clear symptom that you definitely have some type of internal feeder. And then this final picture here, this is a picture of an oak gall, and this is caused by a very, very small wasp that lays its egg or its larva inside a little twig. And as that larva begins to develop, it stimulates the plant to produce all this strange tissue around it. And that larva feeds inside that tissue until it becomes large enough to break out and move on to the next place. So just be aware, if you see some things like this, there are galls that can be created by insects. But then, like we've mentioned earlier, there are some galls that are caused by disease. So that was a lot of information crammed into 2 slides, but now I want to give you a little bit of information and just let you know that there are some key plant relationships that we can come away from this with. And if we become familiar with the types of things that are common on common landscape plants, then that's going to take a lot of the guesswork out of it for us. So we saw the picture earlier of azalea and the feeding damage that the azalea lace bug causes on that plant. That is a key plant relationship. I don't think you'll find an azalea without an azalea lace bug, probably ever. Boxwood leaf miners are common. I don't know if you've noticed a pattern yet, but bugs that have plants named after them are clear signs that those could probably, or more than likely, are related to each other in one way or another. We all know Japanese beetles wreak havoc on our crepe myrtles and many other of our ornamental plants in the garden. They just love to munch on them. Junipers and several other evergreens are plagued by spider mites, so that can cause some browning of the needles. So can bagworms. Cypresses, junipers, cedar trees, those are common things, that would be found on those. Twig and leaf galls, like we talked about with the oak, rose slug, aphids, pecan trees. Everybody's familiar with those webs that are created at the very ends of the limbs of pecan trees in late summer. Those are caused by a fall webworm. Cherry trees commonly struggle with borer issues, canna leaf roller, squash bug. Tomatoes, we all battle cutworms and spider mites all year long. Cabbage, any kind of cold crop, they battle with cabbage worms. And then, of course, cucumber beetles in association with all of our cucurbits. So, and this is just the tip of the iceberg, but these are some that I just wanted to mention and kind of get your brain thinking that there are connections between specific pests and their related host plants. And then here's another list, same situation, key plant relationships, but with diseases. So the slide before was specifically for insects. Boxwoods can be associated with boxwood blight. Hostas, hostavirus, anthracnose. Dogwoods are commonly suffer with anthracnose and powdery mildew. Red oaks that are in urban areas tend to contract a disease called bacterial leaf scorch. I've never had a rose that did not have black spot or powdery mildew at some point in the season. Cherry trees, these poor cherry trees, they have insect and disease key plant relationships. They're plagued by shot hole. That's bacterial disease. Hydrangeas often get Cercospora leaf spot in the late summer or fall. Leland cypresses, which by the way, don't plant them, they get a needle blight. Hollies suffer from root rot. Anytime I go to see a holly that is like yellowing out, becoming chlorotic, it's generally root rot. So that's where your trowel is going to come in handy from your scouting bag there. Make sure you have all your equipment in there. Impatiens, if you plant lots of annuals in your, for seasonal color, you may be aware that impatiens have been plagued with a disease called downy mildew. So they've now bred impatiens that are now resistant to this disease. Liriope commonly gets crown rot. Petunias get a type of crown rot caused by Phytophthora. And pear trees and apple trees are plagued by fire blight, and that's where the tip of a branch looks like it's been burnt and it's hooked over, kind of like we call that a shepherd's hook. So that would be a good indicator word for you to add to your vocabulary for describing insect and disease damage. So I feel like we've spent plenty of time talking about monitoring and the basics on IDing pests in the garden. So now I want to talk a little bit about thresholds. How much is too much for you? And that's a personal decision. No one can tell you what your threshold is. But once you've determined what that level is, and for me, I'm going to tell you it's pretty high. I've got a pretty high threshold for some damage in the garden. I'm willing to lose a few in the name of stewardship, right? So in a vegetable garden, we may want to plant several more plants than what we actually need or want to harvest from, because we're just going to be complacent with the fact that we're going to give some of those plants up to disease and insect damage. So that's one way to handle it. And once you decide what your personal threshold is, even aesthetically, for ornamentals, say you've got a perennial border or a shrub border, around your home or something like that. Once you've decided how much damage you're willing to tolerate on those plants aesthetically, that is when we move on to deciding what the best management strategy is going to be. And of course, we always want to start with the least invasive and work our way up. And that's why I have organized these in this fashion. So we're going to start by discussing some cultural practices, move on to mechanical removal, biological control, and then finally chemical control. So as far as cultural practices go, there's lots and lots of things that we can do. And essentially we want to promote healthy, happy plants. Healthy plants are more vigorous and they're able to withstand pest pressures. And oftentimes they do not attract those pests in the first place because they're not giving off those chemical signals to those pests to come and attack them. So some things I want to keep in mind in the beginning. Let's buy healthy, okay? Don't buy plants that are already diseased. Stay away from peppers that have yellow leaves or tomatoes that have spots on their leaves. Let's buy healthy. Let's always start clean in the garden. We want to plant smart. And I've decided to start using plant smart instead of right plant, right place. I feel like we've used that term, we've overly used that term in horticulture. And so I'm just coming up with a new phrase. We're going to say plant smart. Don't plant a plant that needs partial shade in full sun. A macrophylla hydrangea that prefers some shade is not going to perform well in full sun. It's going to be attacked and plagued with leaf spots. It's going to wilt midday, and it's just not going to be performing at its highest capability, and it's not going to be healthy. Right? So we're not promoting a healthy environment for that plant by placing it somewhere where it doesn't want to grow. The next thing that we can do is use resistant cultivars. And especially in vegetable gardening, I cannot tell you how important this is. So you can see the little outtake here on the side screen, tomato disease resistant codes. Essentially, the more codes that are on that plant tag, the better. That means that you're protected against all of these diseases. Verticillium wilt and Fusarium wilt being two of the most important for tomatoes. So if we just start with plants that are already resistant to many of these common diseases that commonly attack that particular plant, we're already setting ourselves up for for success, or at least a better chance at success. Sanitation is also really important. So if you're doing a lot of propagating, if you are dividing plants, if you are starting seeds, let's make sure that we sanitize and clean all those materials. Even plastic pots, trays, things like that. We want to make sure that we keep those clean and we start off clean. And then some practices, for cultural practices that we can do once we actually get into the season and deciding on planting that crop, we can use crop rotation. Crop rotation is basically alternating the areas where we're planting different groups of crop families. So a cucurbit, which would be cucumber, squash, watermelons, is in a different family than tomatoes, which are in the Solanaceae family. So it'd be like tomatoes, eggplants, peppers. So if we're going to do some crop rotation, rotating tomatoes with eggplant isn't going to do you a bit of good. But rotating tomatoes with, say, one of those cucurbits and vice versa is going to break that cycle that we can get with insect and disease infestations. Some of those disease may be overwintering in the soil. Likewise, larvae of some of those insects or even mature insects might be overwintering in weeds that are growing in the vicinity. So that, we're going to fast forward down to weed prevention. Weed prevention is so important. If we take those weeds out, we're going to have a better chance of breaking those cycles, both disease and insect life cycles. So now we'll go on back up to cover crops, talk about those for a little bit. Cover crops improve infiltration, they can reduce erosion, and again, they're providing an alternate non-host crop for diseases and insects. So that's another way to help you break that cycle. Trap crops can be really helpful. So an example would be like sunflowers, and there's tons more, but certain crops can actually draw insect pests away from your cash crops or your desirable crops. And so sometimes having those, especially in vegetable type situations, could be very helpful. We've already talked about weed prevention, so we'll skip over that. And then finally, tillage. I do want to talk about tillage briefly. So we can bring insect larvae and eggs and even disease spores to the surface where they are killed by sunlight and drying out of that top layer of soil. So oftentimes tillage can help us with reducing some of those pressures as well. And then removal, I don't have that on the list, but I do want to talk about that. Promptly dig and destroy any infested plant materials. Try to clean up any foliage that falls off that maybe was infected, and get rid of those, remove those from the area so that they don't spread to other neighboring plants. And then watering is important. The time of day that we do our watering can be very important. So if we water early in the morning, allow plenty of time for that foliage to dry. By the end of the day, we are going to have a leg up on preventing some of those foliar diseases that like to develop on wet plant tissue. So we've touched the iceberg on some cultural controls. Now I want to move on and talk a little bit about some mechanical and or physical controls that we can implement in the garden. So hand removal, an example would be, plucking off hornworms of tomatoes. I don't really like to touch them, but you could use tweezers and pluck those off and just stomp them right there in the ground if you want. Pruning can be very beneficial, especially if this is a herbaceous or a woody plant. If you have just one section of that plant that's very heavily infected or infested, you can prune that part of the plant out and get rid of it. And that could be a, whoops, I'm sorry, I changed the slides. That can be a great help in many circumstances. Just giving the plants a good shake sometimes can help a lot. I've done that with Japanese beetles. When they're disturbed, they freak out and they fall to the ground. So if you wanted to, put some dishes of soapy water down there underneath your plants and then give them a good shake, shake them right off into that soapy water, that could be a good mechanical, physical removal. Water, stout sprays of water. I've done this with aphids when you have super heavy infestations, like here on the top of this pepper plant. you can remove, 90% of those by a good strong spray of water, and then it's going to make it easier for you to control those if you need to come back in with a biological or even a chemical control. Barriers are good ideas, and I haven't used barriers that much in my own gardening, but there are several things we can do. Copper strips are said to prevent slugs and snails from moving over that area. Sharp crest seashells could be used as a perimeter barrier for ground crawling insects. Cardboard collars could be used for cutworms at the base of plants. So there's lots of different ways that we could implement some barriers in the garden. Traps, of course, are important. You can see we've got one here. This yellow, it's like a yellow sticky trap, and then there's also a white sticky one above it, and that's just to help you with some color contrast. Some insects show up better on different colors. So using these traps can be helpful when you're trying to monitor and scout, just like we talked about the double-sided tape earlier. But also, it can help you with physically removing them from the environment. If they're stuck to this sticky trap, you can't eat your plants. So that could be useful if you put those throughout the garden area. Now, floating row covers can be super helpful depending on what your crop is. So if it's a crop that is not a fruiting crop, so what you're trying to harvest isn't a fruit, this could be a situation where you may be able to use floating row covers like cabbages, leafy crops, cole crops, things like that, because they don't have to be pollinated for you to harvest them. So you could cover them from the very beginning and prevent a lot of issues just through exclusion of those insects from the very beginning, like flea beetles, cucumber beetles, so on and so forth. And then finally, mulch. So mulch prevents rain splash that could happen. Let me start over. So mulch prevents splashes from rain. When the raindrops hit the ground, it splashes dirt that could potentially have fungal diseases in it back onto those lower leaves of those plants. And so if we put a mulch layer down, we're going to prevent the amount of splashback that we have and thus transfer of disease. So now we're going to talk a little bit about some biological controls. So these are fun. We want to encourage beneficials, right? So this is where we could have whole talks just about all of these bullet points right here. We want to encourage those beneficials to come to our garden and help us fight the bad guys. It's important for us to be able to recognize the good guys from the bad guys. We need to provide habitat for them. If we don't have plants that they like, then they're not going to be drawn to our area to help us take care of the plants that we like. Birds can be helpful. Toads, they all eat insects, microbes, and then releasing parasites and predators into the environment can all be useful biological controls. And you may say, well, maybe you've gotten the gist of it by now, but you may say, well, what is a biological control? And simply that's utilizing living organisms to kill pests. That's all it is. We're using things that are alive to help us fight our bad pest, disease, and or insect. So if we encourage insects that help control pest populations like parasitic wasps, lacewings, we're going to get into identifying some of those here in a minute. Using bacterial controls to manage pest populations. We're going to go into a little more detail on that as well. So first we want to talk about some predatory insects. These are beneficial insects that are not pollinators. So often when we say beneficial insect, everybody's attention goes straight to pollinators. Well, we've got lots of other insects that do wonderful things for us that are not, or one of their main things is not, pollination. So here we have a ground beetle. Ground beetles are wonderful predators. They prey on armyworms and cutworms and all different kinds of grubs that may be in the ground. Lady beetles here, I'm sure many of you know by now, they feed on lots of different soft-bodied insects like aphids, mites, and scales. And then we get into some bugs that are kind of like the ambush bug. Now, he'll eat almost anything, good or bad. So, if you see one, you don't have to kill it. because he could be doing some good for you out there. Lacewings are also super beneficial. They feed on the aphids, mites, scales, and they'll even eat the eggs of those soft-bodied insects as well. And then hoverflies, which are great predatory insects. They love to feed on soft-bodied insects also. There are a few more predators that I want to talk with you all about today. So we have the wheel bug. If you can see, this is the picture in the top right-hand corner of the screen, and it has that wheel half circle on its back with the little spikes. This is known as an assassin wheel bug, and they prey on caterpillars, beetles, aphids, also stink bugs, so they can be really great to have around the garden. Next up, we have the milkweed assassin bug. That's the orange and black bug there on the top left. And these are not to be confused with what a lot of people just call the milkweed bug. They do have the same coloring, but these are different insects. So the milkweed bug feeds on the seeds of the milkweed. And the milkweed assassin bug feeds on lots of small types of insects, soft-bodied insects, flies, beetles, mosquitoes. So let's be careful and make sure that we're identifying those correctly. Praying mantids, of course, we all know, are beneficial in the garden. They will feed on almost anything, as will spiders. I've listed orb weaver spiders here, but really all spiders in general are going to be doing some great things for us in the garden. Now I'm going to talk a little bit about some parasitoids that can do some great things for us. The tachinid fly right here, it actually is a parasitoid because it always kills the host, if you were wondering what that word meant. They develop on or within a host. So, for example, this adult female fly lays her egg in or on this host. The eggs hatch and the larvae consume that caterpillar or insect larva. They consume it as they begin to grow, and then the host will gradually die. Blue-winged wasps do the same things. They're right here. These are solitary wasps that actually live in the ground. So if you ever see those coming out of the ground, don't freak out and try to get a wasp and hornet killer spray after them, because they're doing good things. They're parasitizing white grubs that are in the ground. Brachynoid wasps do the same thing. They don't really look like wasps, so you may not notice them quite as often, but they parasitize hornworms. So if you ever see a hornworm that has all these little white sacs on it, let's try not to kill that hornworm. We'll leave him, because in a few days, all these brachynoid wasps are going to come out of those casings, and that is just going to fuel the fire to kill more hornworms so that they can work in our favor. Potter wasps, the one down here on the bottom left, they love to parasitize caterpillars, so they can also be effective parasitoids in pest control in the garden. And I have a slide that talks about, let's make sure we can identify friend from foe. So being able to identify these beneficial insects in all their different phases of their life cycles, but we don't have time. So maybe we can do that again later. And then creating habitat. We talked about this earlier. It's so important. If we can include some of these plants, some which are native, into our garden design, this is only going to work in our favor by providing nectar sources for those plants. And then, of course, we're going to get some great pollination as well. So pollinators will be drawn to these also. Then we want to talk a little bit about biorational control. So we're still in that biological control phase here, where we are utilizing living organisms to kill our pests. Biorational insecticides, they have a lot of different definitions, but essentially they're derived from nature in general. And they have qualities that make them easier on many beneficials. So an example would be Bacillus thuringiensis. BT targets specific species of larvae, depending on what strain of BT it is. And I found this really great description on how BT actually works, and I want to read that to you all real quickly if we have some time. So Bacillus thuringiensis must be eaten by the target pest larva in order to cause mortality. The ingested bacterium is not what kills the larva, but rather a protein crystal produced by the bacterium. The crystal carries a toxin that is lethal to some Lepidopteran larvae. To release the toxin, the crystal's require the alkaline environment found in the gut of a Lepidopteran larva. When BTK is eaten by a susceptible larva, the toxin is released. The midgut wall is destroyed, allowing the bacteria to enter the blood of the target insect, causing death. This process may take 3 to 5 days. So unlike the situation with some chemical insecticides, there is not an immediate knockdown of insects following a treatment. And when I was referring to, I said BTK, that is a specific strain of BT. So BT Kerstocki is the one I was referring to in that description there. And they target Lepidopteras, which do include moths and butterflies. BT israeliensis is another one that you'll may commonly find on the market, and they target Diptera. Those are flies and mosquitoes. And then there are several other strains as well, some that target Coleoptera, which are beetles, and Hymenoptera, which are wasps and bees. So when you're buying BT, let's try to make sure we know which strain we are actually buying to use there. Bavaria bassiana is a fungal pathogen of many arthropods, and it doesn't have to be ingested. It just has to come in contact with the host. And it is found naturally occurring in soils. So that's another biorational control we could use. And then a final example is spinosad. Spinosad is a soil bacterium that also occurs naturally, and a neat fact, it was found in an abandoned rum distillery in 1982, produced as a side byproduct of fermentation. So these are all things that are found in nature that we can use as biological controls to help combat some insect and pest diseases in the garden. Now I want to move on and talk a little bit about chemical control. I realize we're touching briefly on all these areas, but this is an introduction. This is an introduction to IPM. So traditional synthetic pesticides, as well as alternative environmentally friendly pesticides, can safely reduce pest populations and are very important components of its successful IPM program. So IPM isn't aiming at trying to not use chemicals at all. It's trying to use all of the tools in our toolbox to bring that pest population down so that we don't have to use as much chemical or use it as frequently. So I wanted to read you this quote here, because some people are also misled with the assumption that if a chemical is marked organic or OMRI, O-M-R-I, that it is safe or safer than a synthetic product, and that is not always the case. So this quote came out of a reference book called The Organic Gardener's Handbook of Natural Pest and Disease Control. So it's a really good book if this is the type of thing that you're interested in. And that quote says, experience and research has shown that many botanicals are very toxic, not only to pests, but to bees and other pollinators, birds, fish, and even people and pests. For these reasons, sprays and dust that contain nicotine, Sabdilla, Ryannia, or Rotenone are no longer recommended for use by organic home gardeners in any circumstances. Pyrethrins and neem appear to be less hazardous, but even they should be reserved for special use. So just kind of wanted to make that clear, that just because something is labeled organic, it does not mean that it has low toxicity or that it will not affect beneficial insects. But many of these, we can make our decisions on what chemical we use by trying to pick a product that is not broad spectrum, something that is targeted at a specific class or type of insect, whether that be a soft-bodied insect or hard-bodied insect, a sucking insect versus a chewing insect. Even the application method of a product can help us to make better decisions about what product to use. So for example, a systemic insecticide is applied, it can be applied a few different ways, but it is soaked into the plant. And so say for example, an insect that's feeding on that foliage, when they ingest that product, that is when it disrupts their system and kills them. So if there are other insects flying around in the area As long as they're not ingesting that plant material, it would be a safer or a softer product to use to try and save some of those other non-target insects. I hope that makes sense. So again, we always want to select a product that is specific to a pest as possible. Spare damage to non-target insects. IGRs, or insect growth regulators, I want to talk a little bit about those. There are different modes of action that can interfere with the development at any stage in the life cycle of an insect. And these hormone cycles are not present in mammals, and so they have low toxicity to humans, which makes them a product that we may lean heavily towards. Some examples are neem oil. Neem oil is an antifeedant, and it is also an insect growth regulator. Another example of something that you probably use often in your home residence is Alticid, or methoprene. That prevents the emergence of adult mosquitoes. So if you've ever used a mosquito dunk, you've used this product. They develop from the larva to the pupal stage, and then they die. That is not labeled OMRI. I just wanted to make that a side note. So when I said it's an insect growth regulator, it's preventing that larva from moving on from the pupal stage. So that is why it falls into that category. So then we're going to talk a little bit about insecticidal soaps and horticulture oils. These target soft-bodied insects like mites and aphids, and they can spare hard-bodied insects like ground beetles and lady beetles. So that might be a great option for you if you're trying to target some of those soft-bodied insects. Soaps and botanicals, they degrade very quickly in the environment, and they have less impact on non-target. They have the potential to have less impact on non-target insects as long as they're applied appropriately, and they have very low toxicity to mammals as well. The soaps they disrupt the cell membranes of the soft-bodied insects, and so that is how they are effective on those types of pests. Moving on, talking a little bit about horticultural oils. These oils also disrupt cell membranes, and they kill through slow suffocation of the insect. And they can be, I don't want to say toxic, they have some phytotoxic capabilities if they're applied inappropriately. So in temperatures that are too high, or when the sun is too bright, or at the wrong time of day when it's going to be exposed to long periods of sunlight, they can have some phytotoxic side effects on the plant tissue. So we'll be careful using those horticultural oils. And then there are some other things out there, diatomaceous earth. Those would also fall into the biorational controls category, if you will. Wanted to talk a little bit about systemics, and systemics are less likely to affect predators on plant surfaces because they are not feeding on the plant. So I just wanted you to know the difference in systemics and then what we call broad spectrum insecticides. Broad spectrums are sometimes necessary if we have multiple pest presence, hard bodied, soft bodies, sucking and feeding insects. Sometimes they can be necessary, but they do provide that initial drop in population, but they can also encourage flushes a few weeks later. And so we oftentimes need multiple applications of broad spectrum insecticides to get full control. Pyrethrins would be an example, and are probably the most effective against some chewing insects. And I've listed some others here I'm sure many of you are familiar with. Malathion is used oftentimes in the garden setting. Permethrins, bifenthrin, and carbaryl, which is the active ingredient in 7. So moving on, wanted to talk a little bit about fungicides. We're going to start again with the biorational control options. We have Bacillus subtilis. A brand name for this would be Serenade. And this is actually a live bacteria. So we want to be careful where we store it. We want to keep it at room temperature so that we don't, kill that live bacteria by exposing it to extreme temperatures. It is preventative. It is a preventative fungicide, essentially, not curative. It can control anthracnose, bacterial blight, bacterial speck, bacterial spot, rust, downy mildews, late blight, powdery mildews. So it has a wide range of things it can be effective with, but we need to use it on the front end as a preventative, because it's not going to give us any control once we've already contracted those diseases. Now, copper sulfate or other products that contain copper can be found. They're available in powders and soluble forms. And also, we want to use those early as a prevention method. And they're going to control many of those same diseases, including powdery mildew, rust, gray mold, early late blight, and many others that fall in that category. Neem oil, I know we talked about neem oil with our insecticides, but it also has some fungicide properties. So it can prevent powdery mildew, rust, and it obviously is made from botanical extracts. So it's got some things going in its favor there. Potassium bicarbonate, a brand that you might find on the market is called Monterey Old Fashioned. It can control powdery mildew and several leaf spots. And then streptomycin is something that you're not going to find on the shelf at Lowe's, but you can probably order this through a farm supply store, and it's going to be effective with helping us with root rot, damping off if you're doing a lot of starting plants from seed, bacterial leaf spots, and many other things. And then sulfur, finally, can control powdery mildew and rust. Many of them are mixed with insecticides, so we need to make sure that we, check those active ingredients. And if you have for example, a fruit tree spray, it may have sulfur as a component in it to help with some fungal control. And then we move over here and talk about the synthetic control column quickly. These we'll say top three, I guess, would be the ones that homeowners are going to see most often as active ingredients in products that they're going to buy. If you went to the store to buy, your rose had a black spot, you were going to get something to put on it. You just picked up a 3-in-1, rose control or something like that. One of the active ingredients in that is probably going to be chlorothalonil to control some of those fungal diseases like black spot and powdery mildew. Captan is another one that you'll see often. A brand name for that would be Daconil. And Mancozeb, finally, it's a pretty effective fungicide and easily found on the market as well. Some others that may not be as easily found for homeowners is propiconazole, azoxystrobin, and myclobutanil. Now, these three on the bottom, propiconazole, azoxystrobin, and myclobutanil, these aren't going to be found on the shelf, in a box store. These are things that you're going to have to order through a farm supply store. And some of these actually do have some curative properties. So they're a little stronger and have a few different uses than these three preventative ones that we mentioned here at the top. And you may have to order these, and some of them you may require a license to purchase. Now we're going to move on and talk about that last step in the IPM program, and that is to implement your management plan, okay? So go out there, do it. You've done all these observations, we've decided on our threshold, we've picked out the best control method, or maybe we've gone through several of those control methods. We need to record these things so that we can go back and see how effective they were. Say we implemented some cultural controls, that didn't quite do the trick. Then we implemented XYZ mechanical controls. We got, we saw some results, but not as good as we would have hoped. So then we moved on to XYZ biorational or chemical control method. So we just want to keep notes of what we did, how well they worked, so that you can go back and use that as a guide in the future when you are trying to make decisions in your garden and landscape. So I feel like we've touched on every one of these inches here, so you should be inching your way towards the Tennessee Smart Yard as we speak. And just keep in mind that this IPM process, is a cycle. Management is the main goal, not eradication. And I hope you have enjoyed this presentation. This is a list of many resources that you could use to help you in these endeavors and where much of this information came from. I hope you guys have a good day.